Welcome back again. Tommy Gartlin here, Dundalk IT. So here's where things are starting to get really interesting, I suppose. We're putting it all together and we're going to test the range of the various servos that are connected to the various joints in the robot arm. Now here I have my camera set up. I've risen the camera a little bit to try and give you a better view. You can see we have 4 joints on the robot arm. This one has been assembled already, so hopefully you've got to this stage. And this is what I was talking about, the actual servos, that the servo position at 90 degrees, the corresponding joint should be positioned at 90 degrees, and then try and put on the horn or the tab to get it into the insert, so that you know that both the position, the joint that it's controlling, and the servo position are both in mid-range. That's probably the trickiest part. Now it's quite interesting, isn't it? Now that it's finished, we have the mechanical design. Peter's done great work coming up with the design for that and printing it and coming up with instructions to put it all together. Robert designed the PCB so to make it easier to connect the connector of the robot arms. We don't want lots of wire. You can see here mine's a little bit messy because it's got individual wires, because as I said, this is the old version of the PCB where the connectors were sort of the wrong way around. But you should be simply able to come along with your connector and connect it straight into those terminals for the servos. Just make sure that it's orientated the right way around, so the ground is going to ground. And usually ground is the black signal, or well, the ground is the brown signal on the actual the connectors that you get. So, and then I'm actually trying to write the software to control it, and that's running on the actual microcontroller, which is on the Arduino Uno underneath. So it's really been a team effort, and all of engineering really is a team effort. It's very rare that somebody is just going to work and develop something in isolation from other people and skills. It does really require a combination of a lot of people and a lot of different skills to achieve significant results. So that's what's nice about engineering, working in teams and problem solving. So anyway, what are we going to try and do here? We're going to try and test the range of each of the joints. So when I say the joints, we have the shoulder, which is the bottom. It's going to turn clockwise and anti-clockwise. Call this the upper arm, this joint here. This is the lower arm, and this is the claw. Okay, so I want to test the range of each one so that we don't overextend it. If you overextend it, then there's a danger, and I'm a bit worried, that all of this is being powered by the USB cable. There's about a limit of about 500 milliamps. That power is coming from your laptop, your PC, so that it shouldn't do any real harm. But if there's too much friction, or if we go extend over a limit or something, that we might take too much power, it'll cause the system to reset, and you may hear a sort of a ping noise where it's like the USB cable has been disconnected and connected again, and you might have to restart your terminal monitor. Okay, so hopefully you've got your USB connected. You've got your 4 connectors to your 4 joints connected. You've tested your movements, that there's nothing really, that they're all sort of relatively free. And I've created this program called testing range of all servos _8 that's going to allow you to test the range or the limit of each joint. And basically it's PC controlled. It's a PC, in other words, computer controlled robot arm at the moment, because I don't have any joysticks. I'm just going to send the angles to move to using the terminal monitor. Now, one of the things that I've got here at the top is macros: test shoulder, test lower arm, test upper arm, test claw, and you can see they're all 0 except the test shoulder one, which means I can concentrate on one joint at a time, and it'll ask me what position do I want to put the shoulder at. And when it starts up, they all start up in 90 degrees, so they all should start up in the mid position. So there may be some movement when we power up, or you connect in your USB cable and you download this program. They all will try to go to 90 degrees. And we've got 4 servos, as we looked at before, for each of the joints, for each of the servos controlling each joint. 2 important things maybe here are, when we try to move to a particular position, we go up in, at the moment it's step sizes of 1, so an angle step size of 1. We could go in step sizes of 2, and we make a small delay between those steps. So we're going up in small steps. So if we say we want to go from 90 to 70 degrees, then we're going to go up in steps of 1 degree, and we're going to delay 10 milliseconds between those steps. And what we're really trying to do is get a bit of a smoother transition, a smooth movement, rather than this jolted movement that maybe we would have seen earlier on. And that was quite tricky. And these are things that can be tweaked. You can play around with these yourselves. I mean, you could change that to go up in steps of 2 degrees at a time with 5 milliseconds or 20 milliseconds, and you can see the difference it makes. So we understood that we probably needed to do this, and then we just I just tweaked it a little bit to see could I get the most smooth movement possible. But these are the two values that will determine how smooth that movement is. You can see I just got it in the setup. I've just got an initial welcome message, and I'm attaching the servos to the various pins. Okay, they're already wired on the PCB, but I know what they are, and they should be exactly the same for you. And I'm writing the initial position, shoulder position, lower position. They're all set at the start position, which is 90 initially. Okay, so don't worry if you don't understand all parts of this. If there's something that's particularly interesting, you find interesting and you want to understand it more, then you can talk to me during the actual live classes. So you can see if test shoulder, and each one, this code is quite long, you could say, but it's sort of repetitive in ways too, because for each, you can see if test shoulder, if that's a 1, if that's true, then I'm going to test the shoulder. If the test lower arm is a 1, I'm going to test the lower arm. And pretty much the code is the same, except for the names is different, obviously, for each servo joint. If test upper arm, if test claw. And that's what these values relate to. Up here at the beginning, we said, if test shoulder, if it's a 1, we test it. If it's 0, we don't test it. Because in programming, any non-zero number is interpreted as true. The only number that's interpreted as false is 0. And remember, what's in the round brackets here is a test. So if this test is true, we're going to execute the code between this squiggly bracket, which represents the end, and the corresponding one here, which is automatically highlighted, which represents the end. So that's the beginning, and that's the end of a block of code that is only executed if this test is true. And that depends on us, whether we set that test shoulder value at the top to be 1 or 0. So we asked the user what position would they like the arm to be in, the shoulder to be in, and we read that value in, and then we print it out to say shoulder position entered, just to verify that we heard correctly, if you like. And then we have a little what's called a while loop. So it's a finite loop. Now absolute, when you subtract one number from another, it depends on which one you put first, whether you get a positive or negative value. So say the shoulder position is 70, and the value we enter, say the shoulder position is 90 initially, and the value we enter is 60. 60 minus 70 is 10 degrees. It's actually minus 10. We're not really interested if it's plus or minus 10. We're interested that we still need to have some movement, that we're 10 degrees away from the position we want to go to. And while the absolute, whether it's the absolute value, gives us the magnitude, not the sign. So it sort of ignores the sign. So absolute 10 is 10, absolute minus 10 is 10. So while that value is greater than the angle step size, in other words, we keep moving until we're within one step size of the new position we want to go to. Okay, and then it's just a simple case of do we increment step sizes? Is the current position less than or is it greater than the new position? So that means that we add on step sizes or do we decrease step sizes until we get until we get within one step size of the new position. And then we write that shoulder position. So here we're incrementing it by step size, angle step size. So we said above that the angle step is 1, so we're going up in 1 degrees. So if the value entered is 70, or we'll say 110, and the shoulder position is 90, so that's 20 degrees of a difference, which is greater than 1. We're going to shoulder position is shoulder position plus 1. So now it's going to go to 91, right 91, and then a 10 millisecond delay. Go back around again. Now the value entered 110 is minus 91. It's still greater than 1. And we keep going up. We'll have to ground this, in this case, 20 times. So because there's 20 degrees of a difference, the step size is 1 degree until we get to the position. So I'm just trying to explain a little bit of the code to take a little bit of the mystery out of it for you. But let's see how it works. So we upload the program. Okay. And I'm going to go here now to the serial monitor. So you can see that please enter an angle I should have to put in 4 there, don't I, for the shoulder. 90 to 0 is for clockwise, 90 to 180 is anti-clockwise. So up here is where you put send data to the robot arm. So if I, for example, I put in 80, okay, and the next time I'll show you, then I could put in 110. Now you might have heard the robot moving, but it has moved. Now I'm going to put in 70. Okay, so I'm going to do this again, but with the camera on the actual robot arm so you can see what's happening. So as I said, well actually I can show both together, can't I? So let's try and do that. I'll just minimize this a little bit here. Okay, that's as minimum as it goes. I'll put it up here. So if I go back to 90 again, it's the shoulder, so you can see it move. If I go to 80, gone one way. If I go to 100, which is 10 degrees, swings the other way. Then I can go to 70, and I could go to 120. I could go to 50, and I could go to 130. I'm in danger of running into my wires, but as far as I'm aware, there's no limit really on the shoulder except for my maybe poor build here and running into my wires. If I go to 40, maybe move my wires a little bit out of the way and go to 150. I go to 20, and I can hear a little bit of humming there, which means it's probably drawing a little bit more current than I would like. And I'll go back again to 90, and then maybe 20, 90, 160, 10, 170. So maybe, you know, 10 and 100 and 170 is probably as far as I should go. I can hear a little bit of extra noise when I go to 10 degrees, which means it's probably working a bit harder or maybe taking a little bit more current even in that when it's not moving. So just to keep an eye on it, but it seems good. So we could stop that. We could go back to 90. Just to leave it in, I always try and finish off, leave it in the mid position. That means it won't get a jolt when you download a new program, because the programs generally start with everything in the mid position. And I could stop that. If you wanted to go now and test the shoulder, say, and the upper arm together, it's probably a good idea to concentrate on one together. But you can see the last time I wasn't asked for any information about the lower arm or the upper arm or the claw. But if I change this to 1, and change this to 0 and recompile or just upload, it'll recompile automatically then. A little bit of noise there, so tools, serial monitor. You can see now the information is different. It's not about the shoulder anymore, it's about the upper arm. So what you should have maybe just make note of when you do determine what the range is on either side, just make note on a piece of paper, write shoulder lower limit, shoulder upper limit, you know, shoulder lower limit maybe 20, shoulder upper limit maybe 170, or 10 and 170, whatever you feel is safe and is not drawing too much current. But now we're on to the lower arm. Actually I probably wanted to test the upper arm, so I'm just going to go back and change this to 0 and change that to 1 and upload that. Yay! So a bit of a jolt there when I did that. To serial monitor. Okay, so upper arm limit. So say I go 80. Let's put the camera on again. Let's get the serial monitor up before we do this. So the upper arm is this joint here. Enter. So that worked, but I hear it running there, so I'm not sure if I should be overly concerned or not. 100, I'd like to have a multimeter on this or something that I can measure current. So you'd see it's reached, that's good. 70. That's good. 120. You probably need this to be stable as well, held to the ground. Maybe tape it to the ground. And you can see that it's not too far off. It's about maybe 6 centimeters off the ground there at the moment. So what was the last position? It was 100. So we'll go back to 60. Okay, and maybe 120. 50. Probably at the limit there with 50, I would say, or close to it. 130. And maybe getting there as well. So you could say, you know, lower limit 50, upper limit 130, for example, for the upper arm. Then you can switch over and test the claw. We put it back to 90 again before I finish. Just remember to try and put it back to 90. So 90. And there it's a 90 again. Okay, so it's looking good so far. I do a quick test on the lower arm, and then I'll do a quick test on the claw. But you should probably do a little bit more testing than I'm doing here. And it does a little bit of a jump when I upload the program. I'm not quite sure why that is, and that's something I'll have to get time to look into. But for the moment, we can manage with it, I think. So now we're testing the lower arm, which is, I just put on the camera again, which is this here. Okay, so that's the lower arm. So let's see what that does. So if I go 100 first of all, yeah, and 80, and 120, yeah, and 60. So that looks good as well. Okay, and back to 90. Okay. So finally, let's just test the claw. So good idea, always put it back to 90 degrees when you finish it off, otherwise it'll jump to 90 when you start off with the next one. So test the claw, upload that. There we go again. I really don't know why that happens. The shoulder has switched all the way around and come back to 90 again, so it's something to do with the resetting of the device. Tools, serial monitor. So we're on the claw now. The claw is 90 degrees, so say we go 100. See it open, 80. 120, 50. You can see 50 is closed there, so that really is the lower limit for that, but maybe it's too low. Go 60. See, so 70. So 60 is probably the lower limit. No, not there. 55. So 55 maybe. You want to grab something tight, I suppose. So you could say 50. 50 probably is in my case. So make a note of that. 50 is the lower limit. And 120. So we'll just take a note of that, those two, for example. 50, 50, 120. So claw, low limit, and claw, upper limit. So I'll put these into the next program later on when I'm putting in my limits that we're going to control with the joystick. So let's just stop that and see. It is possible to control everything at the same time. So if we put them all to one, whoops, better go back and just make sure the claw is at 90 again. It probably doesn't matter too much for the claw. There you go. So let's set them all to 1. And now it'll go around each one in turn and ask for the position of each movement. So tools, serial monitor. So first is the shoulder. We put the camera up again. Okay, so first is it asks for the shoulder. Them all one, so we're going to be able to control the position of each one. So say when the shoulder is 80. And now it says the lower arm limit is 80. And the upper arm limit is 100. And the claw go 70, 80. And that goes back to the shoulder again, so I could go 70. Okay. The lower arm limit, upper arm limit, lower arm limit. Maybe I should have upper arm before I ask for the lower arm, so I might change that as well actually. And say 100. And the upper arm limit, say 100. And the claw, we'll leave it at 70. So I'm having a hard time remembering, you know, what's opening, what's closed, what's up, what's down. So it might be a nice idea if you take notes of that yourself. Okay, so say, you know, whether the number means going clockwise or anti-clockwise. Whether the number means going, you know, large number means coming back or going out, or, you know, etc. Because if you're just typing in numbers here, it can be quite difficult. But this is probably not something I use to control it for the moment. We're probably going to use the joystick, but I just wanted to show that we could go around each one and test them all together. But initially I would say to just test each joint independently to see is everything working okay first, and to establish what your limits are. What you really want from this program is to establish the limits for each joint. So for the claw, I've written down here 50 and 120. 50 is the lower limit, 120 is the upper limit. So it's all going good. Hopefully it's going good for you too. You can see how it's all coming together. Then the final two parts will be to test the joystick, to maybe give you a little understanding of how the joystick works, and then to actually control the arm using the joysticks, which should be a little bit simpler than controlling them using a PC. But remember, there's different ways that the robot arm could be. In a factory, this robot arm could be pre-programmed to just go through a certain set of movements over and over again, which it quite happily do. That's one of the advantages of robots. They don't mind doing repetitive tasks. But in another situation, maybe sort of a bomb disposal expert might send in a robot and then manually control it using joysticks that are wirelessly connected to a robot. So it depends on the application. But we can see here how we control the robot using a PC, and now in the future videos we're going to see how we can control the robot using joysticks. Okay, so thank you for listening, and I hope you find this interesting. Bye now.